All right, you already know how to deal with simple single-step equations. You probably have learned before how to deal with maybe two-step equations where everything's all nice and in order. Most likely something you were taught to do was draw a line here where the equal sign is. I heard somebody refer to this as make the t-chart the other day. And then we look at x, 3 is being added. To undo that adding of 3, I'm going to subtract 3 from both sides. When that cancels because it goes to 0, that leaves me with x equal to 14 minus 3 is 11. Easy enough, right? Same thing here. X is being divided by 6, multiply by 6, multiply by 6, and that leaves x equal to 24. Simple enough, and these single step ones, you can usually kind of number sense it or guess and check and get close. You don't really have to know what you're doing. But if we focus on order of operations, right, where when we're working, we start at the top and we work our way down. I check for parentheses, is there anything inside? I do take care of any exponents, look for multiplication or division, then do addition and subtraction, and then when I'm finished with all of that, I get my answer, right? So when we're solving, or when we're working a problem, we work down and in order. And this method works fine. You can use that as often as you want, but it's helpful if it's simplified first and everything's on the right-hand side or the left-hand side, wherever it is that you need it to be. You can do all of this without messing with that. There's another way of thinking about it that really helps make it a little more meaningful. And that's something that if you look around on the internet, you'll see is called do and undo, maybe list and undo. And so what we're going to do is we're going to make a list of everything that happens that have to the variable. Okay, so from where it is. So if I made my list of everything that happens up here, I would just say that I added 3. Everything that happens to x right here is I divided by 6. Okay, it's not a big deal. These lists you're going to use in order of operations. Okay, so you're making a list of everything that happens to it. And then what we're going to do is we're going to go through and in reverse order, right? So we're starting at the answer and we're working our way back. We're going to undo everything that happened using inverse operations. Okay, the ones that undo them. So on this one, I would take 11, and since I'm going backwards, I would subtract 3. Okay. It's easier to see with a fresh problem. All right. So we're going to do 3x minus 5 equals 7. So first we're going to make our list. PE, I'm going to leave M and D together because our order doesn't really matter. They're the next step. And then addition and subtraction. So if I start at the top, there aren't any parentheses. There aren't any exponents. There is multiplication. I'm multiplying 3 times x. And then there's addition and subtraction. It's subtraction. We're subtracting 5. And when I do all of that, it gets, there's my answer right there of 7. So to work backwards, we're going to start at 7. Instead of subtracting 5, we're going to add 5. And then instead of multiplying by 3, we're going to divide by 3. And these are distinct steps. So when we get ready to work, I'm going to take 7 plus 5, that equals 12. And then 12 divided by 3 equals 4. So that tells me that my x should equal 4. And I can check that. 3 times 4 minus 5, does that equal 7? 12 minus 5, sure enough, it works. So we know we're good to go. Okay. Now, in addition to solving equations, we've been working with inequalities, so we're going to try the same thing with negative 3x plus 10 greater than negative 8. Okay. Same exact concept. We're going to pull this inequality out for a while, and we're going to think of that like an equal sign. Okay? And we're going to treat it exactly the same way. So x, first thing that happens to x is it's multiplied by negative 3. And then we add 10. And once we've done that, it'll take us to negative 8. And then to undo that, we're going to start at negative 8. We're going to subtract 10, divide by negative 3, and that should give us what our x equals. Okay. So negative 8 minus 10 is negative 18. Negative 18 divided by negative 3 equals positive 6. So that tells me x should equal positive 6. The only thing that's going to be different now is that I had an inequality right here. Okay, so my first thought is to just switch this back and write x greater than 6. But if I test that, we're going to find out it doesn't work, because negative, remember, means opposite. And because I divided by this negative number here, I have to switch my inequality so that my final answer, x less than 6, and when I draw that out on my number line, it's not included, and I want everything to the left. So if I check it, I'm going to pick something that's on this side of 6. 0 is on that side of 6, and it's the easiest one to plug in. Negative 3 times 0 plus 10 is greater than negative 8. 0. So this says 10 is greater than negative 8, and it is, so we're okay. Either way, if you forget to flip your sign, if you're checking it and the number you plug in doesn't work, check one from the other side and see if that fixes it. Okay? It might just be that you forgot to switch your sign. We'll work a couple more together. 7 minus 4x is equal to 3. So if I start at x, the first thing that happens to it is it's multiplied by negative 4, and then we add 7, and that should take us to 3. So I'm going to start at 3, I'm going to add 7, and then divide by negative 4. Yep, subtract 7. I got a little carried away. So 3 minus 7 equals negative 4. Negative 4 divided by negative 4 equals positive 1. Tells me x should equal 1. Okay? And I've changed the way I'm writing this down every now and then. The process is the same. If you find a way that organizing makes sense to you, then run with that. That's fine. I'll show you what it kind of looks like in my head when I'm working these. Say we've got 5 minus x over 4 equals 3. Okay. Now, I'm old enough that GPS hasn't always been a thing, and so when you would Google a place to get the directions, you got the actual directions, and then when you were leaving to come back, you just had to switch them all backwards. Okay. So when I think of it, I'm seeing x, and then the first thing that happens to x is it's been multiplied by negative 1. And then the next thing that happens to it is it's being divided by 4. And then the next thing that happens to it is we're adding 5. It's positive 5 sitting out there. We're adding it back to the x. And that takes me all the way to 3. Then we turn around, start at 3. If I'm coming back, I'm not going to the right, I'm going to the left. So I'm going to subtract 5. And then multiply by 4. And then divide by -1. And that should tell me exactly where we started from. So 3 minus 5 is -2. Times 4 is -8. And then divided by -1 is positive 8. So this tells me x should be 8. Because my last step connects right back up to x. And if we check it, 5 minus 8 divided by 4, does that equal 3? That's 2. 5 minus 2 is 3. So we know we're good. Again, we're going to check on one more with an inequality. We'll look at the same one. 5 minus x over 4 is greater than or equal to 3. So again, if I start at x, the first thing that I see happens, and I could change this. I could just say that this is -1/4 and multiply that way and do it in just the one step, or I can split it and do it twice. This is the other benefit of the method, is I don't have to deal with fractions if I don't want to. Since we split them here, we're going to do it all together here. First thing that happens to x in this case is multiplied by -1/4 and then add the 5. It still takes us to 3. We still turn around at 3 and subtract 5. And then we're going to divide by 1/4. Once you've got your calculator, you're going to put it in parentheses and deal with it that way. Okay? It's not a huge deal. You're okay. And that'll take us back to x. Because again, we're thinking of this like it's just an equal sign for now. Okay? So 3 minus 5 is -2. Now, -2 divided by 1/4. If you're going to use a calculator, put it in parentheses. If you think back, you should remember that you're going to flip that and multiply. You're still going to get, I left out my negative, +8, whichever way you go to get there. Even though this version is an extra step, it's a little bit easier because we don't have to deal with fractions. All we really have to keep up with is the negatives where they show up. But if you can see this and work with it, then go for it. Okay? So again, we've got x. If I keep my symbol greater than or equal to 8. So on a number line, there's 8. It is solid because it could be 8. And then greater than is going to go this way. So to check it, I'm going to pick something on the other side of 8. Let's do 10. Okay, we're going to plug it right back in. 5 minus 10 over 4 is greater than or equal to 3. Well, 10 divided by 4 is 2.5. 5 minus 2.5. Is that going to be greater than or equal to 3? Well, 5 minus 2.5 is 2.5. Is that greater than or equal to 3? No, it's not. So this one doesn't work. Why doesn't it work? It's on the right side. This says greater than. It doesn't work because we divided by this negative right here. And negative means opposite. So maybe we need to switch sides. Something on this side of 8, I'm going to pick 0 because it's easy. 5 minus 0 over 4 is greater than or equal to 3. 5 minus 0 is greater than or equal to 3. So my shading should have been over here. And that tells me my inequality needs to change directions. And my final answer, x is less than or equal to 8, is the one we needed.